Welcome to The Explainer. Today we're tackling a massive global logistics nightmare that actually became a harsh reality in early 2026. The Strait of Hormuz, which is literally the single most critical energy choke point on the entire planet, is facing an unprecedented disruption. And what we're going to explore today are the solutions to fix it. Specifically, we're going to dive deep into two monumental $60+ billion mega project proposals designed to completely bypass the strait. We're talking about absolute world-building engineering here, the kind of stuff that will completely redefine global trade.
To put the sheer scale of this into perspective, normally, nearly half of China's oil supply, roughly 70% of South Korea's, and almost all of Japan's passes right through the strait. But the world's entire bypass infrastructure, meaning every single pipeline ever built to get around it, barely covers 25% of that normal flow. That means 75% is effectively choked off. The global economy honestly just hadn't built any real redundancy for its most vital energy route.
Okay, let's dive into this. You might be wondering, how do tankers currently bypass the Strait of Hormuz? Well, the terrifying answer right now? They generally don't. The railways can't carry oil at this massive scale, and the giant canals that could theoretically replace the strait are, well, still just drawings on a whiteboard. Tankers that can still operate are being rerouted through existing limited pipelines wherever the infrastructure allows, but the current capacity is just drastically insufficient.
So here's our roadmap for The Explainer today. We'll start with the Hormuz bottleneck crisis, then look at the UAE's geographic cheat code. After that, we'll compare the 10-pipeline emergency solution versus engineering the mega canal. Then we'll break down the threat and defense matrix, and finally, we'll weigh the ultimate bypass choice.
All right, let's kick things off with Section 1. The Hormuz bottleneck crisis, a choke point disrupted.
For decades, just the threat of closing the strait was enough to send shockwaves through global shipping. But since February 2026, those worst-case contingency plans are no longer theoretical. By March, drone strikes actually hit the oil terminal in Fujairah. This confirmed something absolutely crucial. Bypass routes are now frontline targets, not just safe, peacetime alternatives. The threat to this 21-mile contested waterway and its alternatives is a very real active crisis.
Moving right along to Section 2, the UAE's geographic cheat code, the 72-mile shortcut.
So why the UAE and not another massive oil producer? Well, countries like Kuwait, Iraq, and Qatar are entirely Gulf-locked. They're trapped completely inside the Persian Gulf with no practical way to route oil around the strait without crossing into another sovereign country. What about Saudi Arabia? Actually, its nearest alternate coastline is nearly 750 miles away from its Gulf oil fields. But the UAE, it has a dual coastline. There's just 72 miles of land separating Port Khalid on the Persian Gulf and Fujairah on the Indian Ocean. To put that in perspective, that's shorter than the drive from New York to Philadelphia.
It's really a geographic position that no other Gulf oil producer can match. This exact 116-kilometer, or 72-mile corridor is the absolute foundation of a massive infrastructure plan detailed by the Atlantic Council. They appropriately named it Operation Overflow.
Which brings us to Section 3, the 10-pipeline emergency solution, the fast track.
If we expand on a successful template from an existing 2012 pipeline called ADACOP, we get some pretty amazing, scalable math. A single 48-inch pipeline across this corridor moves roughly 2 million barrels per day. Build 4 of them, you hit 8 million. But if you build 10 parallel pipelines, you reach 20 million barrels per day. That represents a full, complete replacement of the Strait of Hormuz flow. And honestly, the best part of this plan, each pipeline that goes online starts delivering capacity immediately. You don't have to wait for the entire 10 to 12-year project to finish before that first barrel moves.
But of course, it's definitely not cheap. We're looking at an estimated total system cost somewhere between $40 and $60 billion for all 10 lines. Yeah, billion with a B. That is a monumental figure. Keep this number in mind, though, because it's actually far cheaper than the canal alternatives we're going to look at next.
It's also incredibly difficult to actually build. The UAE corridor isn't just flat, easy desert. It transitions straight into the Hajar Mountains. We're talking peak elevations of 5,900 feet and dense, fault-riddled aphyarite rock. You'd have to build over 20 major industrial-scale pumping stations because, unfortunately, crude oil doesn't just flow uphill on its own. On top of that, ground temperatures regularly exceed 122 degrees Fahrenheit, so you need continuous thermal tracking because steel expands and oil breaks down in that kind of extreme heat. And finally, you absolutely must install full-length fiber optics for real-time leak detection.
So, the crucial point here, and this is a huge caveat, is that pipelines carry crude oil only. Refined products, things like diesel, jet fuel, and liquefied natural gas, they have absolutely no bypass at all without a canal. If you only build pipelines, those refined products are still completely trapped in the Gulf.
Let's move to Section 4 and see how this builds into the next idea: engineering the mega canal, the long-term vision.
Because of that crucial caveat regarding refined products, there's a fiercely debated second megaproject: an inland maritime canal. Think of this as a Gulf equivalent of the Suez Canal, open to any vessel type, moving in both directions. To handle very large crude carriers, which are massive ships that stretch over 1,000 feet in length, this channel would need to be up to 1,000 feet wide and 82 feet deep. The scale of excavation here is just staggering. We're talking about moving up to 4 billion cubic yards of rock and sediment right through the Hajar Mountain range. For context, that's roughly equivalent to digging out the modern Suez Canal 10 times over.
Next up, Section 5, the threat and defense matrix, protecting the lifelines.
Now, if you concentrate all this critical global infrastructure into one tiny 72-mile corridor, you're basically painting a giant target on it. It's much like the devastating 2019 strike on Saudi Aramco's Abqaiq facilities, which knocked out millions of barrels without any warning at all. Defending Operation Overflow requires a really complex, multi-layered matrix. We're talking missile defense systems, buried pipeline sections, redundant pumping stations, and sustained naval protection. But what the Defense Horizon Journal points out is fascinating. The highest probability threat actually isn't a missile, it's cyber. Pipeline control systems managing pressure and valves have been hacked before in multiple incidents worldwide. Hardening those cyber defenses is statistically the most vital protection measure of all to keep this whole infrastructure running.
And finally, Section 6, the ultimate bypass choice: pipelines versus canal.
Bringing all this data together, how do these projects objectively stack up? Well, the 10 pipeline system costs $40 to $60 billion, while the canal will cost $70 to $100 billion, and actually possibly well over $200 billion if they route it directly through the toughest parts of the mountains. The pipeline system takes 10 to 12 years total, but offers that phased delivery we talked about, meaning capacity starts flowing the second the first line is done. The canal takes 10 to 15 years, and it's a total all-or-nothing endeavor, but the massive trade-off is cargo capability. The pipeline is crude oil only, whereas the canal guarantees total shipping freedom for all vessels and those precious refined products.
And we really have to contextualize these construction timelines with geographical reality. Just for comparison, the Dakota Access Pipeline in the U.S. covered 1,100 miles of flat ground in just 10 months. But a single pipeline in the UAE, carving through that unstable, fault-riddled ophiolite mountain rock, that takes 4 to 6 years just to build one line. A full maritime canal through that exact same demanding terrain, 10 to 15 years is the standard estimate. That difficult mountain terrain drastically slows down what would normally be rapid construction.
So, what does this all mean? After examining the unmatched geographic advantage of the UAE, the staggering costs, the intense engineering hurdles of the Hajar Mountains, and the absolute necessity of robust cyber and physical defenses, we're left with a massive global decision. Do you choose the emergency speed and the immediate capacity of the 10 pipelines, or do you commit to the ultimate, long-term shipping freedom of the inland mega canal? 10 pipelines or one mega canal? Which would you build? Think about that. And thank you so much for joining this explainer.